On this question, we want to find the domain of the logarithmic function f of x equals log of 2x plus 10. Now, in order for us to know how to find the domain of a logarithmic function, we have to know a little bit about logarithmic functions. So a logarithmic function is of the form y equals log base b of g of x. So this g of x can be any expression, and it is equivalent to this exponential expression. Logs and exponents are inverse operations of each other, so there's an equivalence between these two, and this is that equivalence. So you'll notice that the base of the log is the same as the base of the exponential. The log equals y, and y is in the exponent. So a logarithmic expression is really an exponent. And then this exponential expression equals g of x, and that is what we have inside the logarithm, the expression we have inside the logarithm. Now, some other information that is important is that we have some restrictions on the base. The base is only allowed to be a number that is greater than 0, and the base is not equal to 1. And we have this restriction because we want for these functions to all behave similarly, and they only behave similarly when we make that restriction of having the base greater than 0 and not equal to 1. So we can identify that we have a logarithmic function when we have a variable inside of a logarithm. This last paragraph that you see over here is talking about how we can find the domain of a logarithm. The logarithm of a negative number is going to be undefined. We can talk about that in detail in a second. The logarithm of 0 is undefined, and we're interested in finding where the function is defined, and that is only for positive values. We would like the expression inside the logarithm to be positive. So in order to find the domain, we would create an inequality to solve. And that inequality is the expression inside the logarithm greater than 0. So that's how we guarantee that the expression inside the logarithm is positive. So if we're able to create this inequality and solve it, that will give us the domain. So for ours, the expression inside the logarithm is 2x plus 10. We create the inequality of 2x plus 10 is greater than 0, and we solve. So we're going to subtract 10 to get 2x is greater than negative 10. We're going to divide by 2 to get x is greater than negative 5. So if we think about that on our number line, we would mark negative 5 with an open circle because we don't want to include negative 5. If we included negative 5, that would cause a 0 inside the logarithm, and that is undefined. And we want the values that are greater than negative 5. And so that's negative 5 to infinity. So this will be our domain. So anytime you're looking for the domain of a logarithm, you're going to take the expression inside of the log, create that inequality where you set that expression greater than 0 and solve, and you will get the domain from that inequality. Now I want you to notice here that I've used a parenthesis on the negative 5. Parenthesis has the same meaning as that open circle. It means that that point, that negative 5, is not included in the domain. If we were to include it, we would use a bracket. But remember, we're not going to include it because it causes a 0 inside the log, and that is undefined for the log. So I said I'd come back and take a moment to talk about why the logarithm of a negative is undefined. So it goes back to being the fact that logarithms and exponentials are inverses of each other. So if we were to try to think of log, let's say log base 3 of 0, so I'm substituting a 0 into the log. When we work this out, this is something that's not going to make sense because it's something that's undefined. So I'm going to try to relate it back to its exponential form. Log base 3 of 0 is some power. If I write this as an exponential, that's 3 to a power equals 0. And when I do that, I'm following this relationship here. This is the definition of a logarithm. So when we think about this statement, 3 to a power equals 0, we come to realize that that can never happen. There is no power that I could come up with, no exponent that I can come up with that would give an answer of 0. And so we get this expression being undefined. The same thing happens when you try to do the log of a negative number. If you try to think about it, you're going to say, okay, this equals some p, which is a power. Rewrite it in its exponential form. You get 3 to a power equals negative 1. And you can see once again that this can never happen. You cannot take a positive number and raise it to a power, a real number power, and get a negative answer. And so once again, we get an expression that is undefined. So this idea of relating the exponents and the logarithms only works when the value inside the log is a positive value. Okay, so I kind of strayed for a minute from the details of the problem, but just to make it focused, whenever you're trying to find the domain of a logarithm, you're going to take the expression inside the logarithm and create an inequality. That inequality is the expression inside the logarithm greater than 0. Then you solve that inequality. And then from that inequality, you can graph the number line and also write the interval notation for that domain. And we got -5 to infinity. Thank you for checking out my videos. Have a great day.